moving along, let's talk about sp2. So sp2 occurs when we still have this promotion, or excuse me, rather, I misspoke here. So sp2 happens when one of our electrons, one of our p electrons is left out, and one s and only two p's hybridize. So sp2, one s and two p's hybridize, and we've got one leftover p orbital. Okay, that ends up looking something like this, where we've got our, one electron in each sp2. But then, of course, in the case of carbon, we will have one extra electron in that p orbital, whether it's the top or bottom lobe. Okay. And if I look at my basis set, it looks something like this. And these are already normalized, and we're not going to normalize these. I'm just giving them to you. Okay. And now if I scan down here, I've got my sp2 wave functions all drawn up. Right there's my 2s plus root 2 of 2py, which you can see there, 2s plus root 2 of 2py, and so on and so forth. And when I look at this shape now, look, it's planar. So if I hold it up to this axis, right, we can see that it makes a plane. And there's only 3 of those lobes. And if you look at this, you should recognize it's 120 degrees. Okay? Beautiful. So we can see that 120 degree bonding angle, right? And we also, right, there's going to be another one of those lobes right there, and then another one of those lobes right there, as indicated in my picture. Okay? And what about that empty p electron, right? Well, that p electron is primed for forming pi bonds because it's going to be off axis, right? Remember, if I want to make a bond from this sp2 hybrid orbital, I'm going to have, right, a z-axis going down this way or down the other two, and that empty electron in the p orbital right there is going to be off axis. So that's prime for making a pi bond. And so we can see that here with ethene, okay? So we recognize that each carbon is sp2. And here we can see the green sp2 orbitals, right? They are forming overlap through that internuclear zone. So that's my z-axis. So that makes a sigma bond, right, as shown right here. But now, right, remember I had one extra electron in that p orbital that was off axis. So that's perfect for making a pi bond, which is where we see in ethene a pi bond and a sigma bond. And additionally, we can draw up a new coordinate system for the carbon-hydrogen bonds, right? We'll have a z-axis for that sigma bond. We'll have another z-axis for that sigma bond, and so on. Okay? And so